Thanks everyone who's online today to listen to what people have come to say about weeding technologies. I was excited to introduce the section about the finger weeder from Einbock because earlier this year we had one of our annual in-field field days where we were visiting growers, and one of those properties that we visited was the large aggregation managed by Nick Raleigh of GoFarms. And at this field day, Nick outlined to our growers and agronomists the technology which they'd implemented on their farm, which he'll discuss today. And that was really valuable to our members to see and hear about this technology which they'd imported and started using. And so hopefully, yeah, you'll get a similar value today out of hearing about this from Nick. Yeah, I suppose before wrapping up, Andy mentioned that I'm representing the APTRC, which is the Australian Processing Tomato Research Council, and our purview is to deliver innovation and research to the processing tomato industry within Australia. And yeah, this extension side of it, hearing from Nick infield was part of that. And yeah, so thank you very much, Andy and the others. Nick, I'll hand it over to you to take it away.
I represent GoFarms Australia, a specific investment mandate of ours called Sandmount Farms. It's in the region of Katunga, Northern Victoria, so approximately 40 minutes drive directly north of Shepparton, in the Golden Murray Irrigation District. We have Shepparton to our south, Cobram just to our northeast, and Echuca to our direct west, to give everybody an idea of where we are. GoFarm is an investment-based business in Melbourne. The project we have here, for context, is a land bank of approximately 6,300 hectares. Our remit presently is land use change. We're growing as well as processing tomatoes, and that's the relevance of today. Our tomato enterprise is a 320 hectare multi-year supply agreement that we hold with Kagome Australia, who are based in Echuca as a major industrial scale processor of tomatoes. Our environment for producing the crop is open field grown. We're using seedlings to establish our crop. We're on a 1.52 metres, which is an old Imperial 60-inch bed, and we're using subsurface drip irrigation spec'd at around about 12 millimetres per hectare per day of irrigation supply at peak demand. We're planting our crop in October and November at around about 18,000 seedlings per hectare, with a target yield of 120 tonne. So it's a short season crop relatively, sort of 130 to 40 day growing window. Very intensive, open field grown, fairly high value. So it's an interesting space. Zooming in, I guess, on the topic of today, weeds. The processing tomato industry, tackles lots of risks, but weeds are a really big one. There are very, very few effective chemical weed control options in the industry, and that's all around the world. It's not just something that we have here. So it's a really common problem. Generally, cultivation plays a really big part of what we do, but traditionally it's really low tech, and by that I mean, toolbars that are clamp and wedge style equipment. Lots of brawn, lots of steel, but not a lot of finesse typically. And then chipping has traditionally formed a big part of the industry and weed control, but clearly that's really, really high cost and highly variable results. So yes, we will do it, but it's something we desperately want to get away from and not be subject to. Our weed pressure, pretty much every summer broadleaf weed you can think of. Grass weeds don't present as much of a challenge, but the weeds, for reference, common heliotrope, blackberry nightshade, fat hen, portulaca, pigweed, depending on the field, maybe some wireweed, probably some Bathurst burrs. They're all, they love warmth, they love water, and they love fertiliser, and we're really good at providing all of that. It's just really hard to get on top of them, and once they get away, of course, they're very invasive. As I said, very, very few effective post-emergent control options coming from herbicides. So a really typical weed control plan in the industry would look something like the following. In our pre-planting period, we would be using methamphetamine sodium. It would be applied in a band of approximately 20 to 25 centimetres that's directly over the plant line. I'm not sure, who in the audience has used it. It's an old chemistry. There are really substantial WHS implications. It's expensive. When I say expensive, even in a band, it's around about $330 a hectare that we're dealing with. And anybody who's ever had anything to do it will know that it's most unpleasant, and it presents a really material risk to our staff, which none of us like. That's about it. There might be a little bit of use of some trifluralin in a band. There might be a little bit of knockdown work prior to the planting of the seedling, but it's a pretty light touch given the magnitude of the risk. Early post-emergent, this is our really narrow window of control, and it's driven largely by metribuzin, so Mentor or Sencor, in combination with rimsulfuron, which is brand name Titus. We can only target really small weeds, and when I say really small, in the example of blackberry nightshade, cotyledon, so the very, very narrow application window. And we can't apply these products, particularly the metribuzin, directly over the growing tip of the plant. So we're working on off-centering nozzles and trying to get them in underneath the plant in a really narrow window. So it's reasonably specialised bit of work. And then post-emergent, well, we've got some cultivation, which has traditionally been rudimentary, and chipping, and that's the human factor, which I've touched on. What are our goals in all of this in our weed control? Clearly, first thing, and particularly we're a corporate business, we want to reduce or ultimately remove the use and the reliance on methane. It's an unpleasant product. We want to reduce the reliance on human accuracy and attention to detail. Total numbers of people in the field, the very high cost of having them there, and the care factor, diligence and supervision and management and the I don't care component is really material, and that leads to problems. We've got a goal of starting down the track of an autonomous future. We're excited by this. We think it's real. But we don't think we're there yet, but we want to get there. So we're heading down that path. We want less reliance on the very few chemical options that we do have, and certainly less reliance on chemical overall. Our alternative options, is plastic mulch an option for us? No, it isn't, because the crop is machine harvested. There has been some work done on some biodegradable spray on plastic polymer type things. We've had a little look at them a few years ago, but it's not anything material yet. Herbicides, we don't think they're a good option because there's just nothing new coming at us that we're aware of, not in the industry globally. So, that's a pretty slow burn. And so ultimately it's back to tillage. And I think, Andy, you said it at the outset about, developments and advancements of the old technology, and obviously that's ground engaging tools. There's various companies providing new and different options. There is a lot of non-chemical option being driven particularly out of the EU, which we think is really quite interesting, and elsewhere, but certainly the EU is very strong on this. And steps toward autonomy, as I say, are making some progress. We've arrived at a product that we've chosen and we've invested in. It's manufactured by Einbock out of Austria. It is the Chopstar model or version. We've equipped ours with what's called Rowe Guard, which I'll talk about in a moment. We've chosen this for some really key reasons. First and foremost, we've got dealer support, and Justin's going to talk to us from Bin Rowe Machinery in a moment, but that's critical. You know, we have a saying in our business, pioneers get the arrows and settlers get the gold. We want technology, but we don't want to be too pioneering. We want to just make sure when we choose something, yes, it's advanced and yes, it's going to take us into the future, but it's got the fundamentals of it's proven and it's got support and it's, you know, it's just not too left of centre. We're running a 4-row machine, so 6 metre width. We're using 8 parallelogram row units, so they're sort of either side of the plant row. The row guard system is equipped, which is basically cameras controlling a hydraulic headstock to steer the machine. We did buy a machine with the manual seated position for a backup in case there was a failure. So if the cameras failed, we can actually position someone on the machine and they can control the machine by steering it. It folds up for transport. That was important for us because we're in an area with lots of narrow bridges and tight roads. There's a huge range of tooling available with this equipment. There's a whole range of other things that Einbock do, and so we're quite impressed, I suppose, with all the tooling options we could have chosen from. And it runs the plastic finger weeders, which you'll see here in a moment. And in my view, you know, these are the really essential option. At the end of the day, this thing is a cultivator. That component of it's not new. I guess it's how well refined it is, how sharp and fine the blades are. But then it's the row guard that allows us to get really close to the plants, and then the finger weeders to clean up weeds very, very close to the plant line. The row guard is critical for the function of this machine. It's, as I say, camera controlled, hydraulically steered headstock. Our experience was very simple to set up. We only used it in pretty basic settings. We were learning, but certainly lots of refinement possible that we're yet to really, I guess, interrogate. There should be a picture coming up in front of you, which I've just lifted out of the Einbock materials that I had, just to give you a bit of an idea of what the machine looks like. This is not exactly the same as ours, but it's very, very similar. So you can see there's guide wheels and depth wheels, and there's little concave cutting discs to allow us to get really close to plant lines, and then every row unit is on a parallelogram, which allows us to follow the contour of the soil really closely. I have another photo here. This is actually our machine on the day it was delivered, and when I was invited to make this presentation, I realised I must have spent too much time looking at the machine and operating it and not taking photos of it. So my apologies that the photos are a little bit substandard, but you get the idea. Like a lot of machinery out of Europe, it is not massively robust. You know, that's not uncommon, but I mean, at the end of the day, it's a fairly refined and delicate piece of kit, so it needs to have lots of moving parts. You can see, I trust you can see perhaps my cursor moving, but here is the individual row parallelograms. These are really accurate, they're really well balanced, and allowed us to get really close to the plant and follow the contours. And you can see I hope you can see my cursor moving, but this long chrome bar here, there's actually 2 of these on the machine, but this is the slide, I guess you would call it, on where the headstock actually moves and allows the machine to be steered. And there's just another side view of some of the tooling that we had fitted to it. Not the best photo, I'm sorry, but you get the idea. There's lots of there's just endless adjustments and different tooling options that can be fitted. And then probably the most important part, it's these plastic finger weeders at the back. So that's at the rear of the machine looking forwards. You can see in there, and this machine is not adjusted into operating position, but the gap between these discs, we can get really, really tight. So the plant row passes between those discs. We have them running at around about 150 mil wide, that gap. So it gives you an idea. And of course, that's dictated by plant size as well, but it's fully adjustable, but really, really tight. And then in doing so, we can then run the finger weeders very tight as well. And the finger weeders are just ground driven. So they're actually, they're engaging with the soil and they're just driven at the same speed that the machine is traveling. So, and they just create really effective disturbance of the soil, and they're pretty amazing at actually ripping out small weeds. I mean, all of this is targeted on small weeds. This is not None of this equipment is for tackling big weeds. I have a video here, and I'm just going to let it play through, and then I might just rerun it and point out a couple of things. I'll just let it play through for everybody first, and then I'll rerun it and just point out a couple of key things. The key thing I point out is the finger weeders here. You can see the yellow finger weeders at the rear. Now I've got them running pretty close. It's hard to see in the video. They are running almost over centering in the plant line. They don't need to be crossing over. They will rip out tomatoes or any other vegetable seedling for that matter. It's just the level of disturbance that they create is really effective. And when we had them set appropriately, it was amazing how gentle they were on the tomatoes. The tomato seedlings really hardly move, so it was really, really effective. And then I will just try and play it again. I just point out the movement of the machine on the sliding headstock. This is being driven by the camera. The camera's on the right-hand side of the machine, or the right-hand side of the screen, the left-hand side of the machine, and that's controlling the steering mechanism here. So I'll just run that through, and you'll see that quite easily how it's moving and steering itself along the plant line. So the key points for us is how we got the machine to work its best. It was running at around about 5 kilometres per hour was probably the best for us. The finer the tilth of the soil, the better. When there's clods present, there's a fair bit happening down there on the ground level. The clods do get thrown around, and it was actually clods that were hitting the plants in rougher conditions that was doing the most damage. The finger weeders, I can't speak highly enough of them. They get really close to the seedlings. As I say, they're almost crossing over in the plant line. They are really effective at ripping out seedlings if you get too close. So, there's still a fair degree of setting up and keeping an eye on it. But they're really a critical inclusion. Our experience was when used in conjunction with the Mentor and the Titus, the metribuzin and the rim sulfuron, it was a really effective combination. It took a bit of the pressure off getting because we do 2 applications of those herbicides, it took a little bit of pressure off the follow-up application. So in conjunction, it was a really great tool. We did have a few issues with shading with the cameras at various times of the day. So casting a shadow, for example, from the tractor, if the sun was on the opposite side of the camera. So that did create a little bit of challenge for us at times. We resolved that by changing the fields and getting a different row direction. I think we can do some more work on that this year with settings in the camera. I just didn't do it in the first year. The machine itself is really easy to set up. There's lots of bolts and there's lots of things to undo and tighten up, but it provides massive amounts of adjustment. I was really pleased and surprised with how hard wearing the ground engaging tools were. I wasn't sure. I was curious and a bit concerned about that coming out of European conditions, but I was delighted with how effective they were. They just haven't worn, and we're in quite sandy soil, which is very abrasive. And I guess we were really pleased and how accurate and responsive, I guess, the hydraulic headstock, the camera, the system was right from the get-go. So that's our experience. It's been a really great tool. It doesn't solve for every problem. It's a tool, as part of a whole program. But I hope that's been informative and certainly available for any questions.
Yeah, I've got just a couple of slides which I've taken from Einbock, which I guess just will talk about the technology a little bit, just behind what Nick was saying. Yeah, so I work for Vinroad Farm Machinery. We're the importer for the Einbock product out of Austria. I'll just go through a little bit of the technology that's involved with the row guard system and the finger weeders. So the row guard unit is a linear shifting hydraulic driven side shifting frame. We like to fit the Chopstar, the Einbock Chopstar machine onto the Einbock row guard, but it actually can have any cultivator fitted to it. It comes with uses a camera system which uses 2 high definition lenses. We have the ability to select colours, so we can differentiate between blue greens, green yellows and reds. We have a 3D mode, which helps in certain conditions with row heights. And we'll just go through a little bit. As Nick was saying, on this steel, this chrome rod, we have a total offset of about 500 millimetres. So as the camera follows the line, regardless of where the tractor's steering, picks up on the plant row or the multiple plant rows, and can adjust ourselves up to 500 mils left to right. It's proportional valve, so it's very, very smooth, very, very accurate. And depending on speed, we have the ability to increase or decrease the sensitivity, so it follows the row really nicely. When we talk about, I guess, standard weeding or standard cultivating, on an example of a 50 centimetre row, Einbock was sort of saying, without any assistance, we work on about an area in between your plants. There's about 74-75% of the area is hoed, because we have to allow ourselves to have a little bit of movement for human error, for GPS, depending on how the rows are planted, etc. Once we bring row guard into it, we have the ability to close the tooling up a lot closer to the plant, and gets us nice and close to the plant. Still doesn't get us in row, but gets us right nice and close to the plant. And then if we add the finger weeders on the back, we have the ability to actually, if we want to actually cross into the row, like Nick said, depending on the plants, tomatoes being a little bit sensitive, we keep them a bit wider. With some plants, and I'll show a picture later, which are a little bit more hardy, i.e. corn, we can actually get those fingers in between the plants and disturb the complete row. When I was talking about colours, this is a bit of a representation, and we have the ability to set in a 2D mode. We can look for more what they call green blue, so you're looking for your darker greens against your weeds. We can change up to green yellow to look against your lighter greens, i.e. corns and sorghums. And if we're using in things like cabbages, red cabbages, we have the ability to go to a red mode. So the camera will try to identify those colours predominantly. Well, it will identify those colours predominantly, and assists itself to follow the row. In the 3D mode, we tell the unit the width of the plant, the row that we're following, and the height, and it identifies that against its surroundings. Can be used sometimes if there's heavy weed cover and the colours of the weeds versus the plants that we want to weed around is very similar. This sort of shows us just our screen and our setup and what we'd expect to see when we're hoeing. We have your signal bar to tell us how good a signal we're getting from the camera. We have the ability to adjust the sensor, adjust its working range. Ultimately, plants have to have a little bit of, we do have some limitations. We've got a plant size of 1 centimetre and a minimum row spacing of 12.5 centimetres. It needs to be able to, I guess, relying on the camera to identify where the weeds are, to identify where the row is, and it still has some limitations. In other circumstances, you can actually fit a secondary camera, and that will allow the system, it will pick what it's picking up as the best row. Secondary cameras, whereas it probably won't be so popular in Australia because we use headlands, in certain parts of Europe where they want to use the entire field, they will still plant around the outside, and then they will plant the rows up and down the field. And if you're using something like a section control, as you come to the end of a row, one camera will suddenly lose the row where the other camera can keep following it. And we sort of move on to the finger weeders. So we have the finger weeders as is on GoFarms machine. And that's predominantly what we have used in Australia. Got several units out there using this system. We do have a demonstration unit which is fitted with the rotation weeding element, which we haven't really played with. Particularly, it's a little bit more aggressive, and we've just been a little bit hesitant to put it into practice, just because we don't want to damage any crops. As Nick was saying, they have their weeders, their finger weeders spaced depending on the plant size. This is sort of what you'd say would be a base setting to start with. You would adjust them in, put a finger between them and try and get them nice and close to the plants. The closer they are to the plants, the better option you have of breaking up that material in the row. But as Nick said, if you go too close, you'll start to do damage to plants. You can see here, we're talking in this top right picture here, you can see where it's just gone through with the straight cultivator, and we still have that little bit in the row that hasn't been broken up. And then if we look at the lower picture, you can see where the finger weeders have gone through and just disturbed that ground, knocked the weeds out. You can see here on that lower right picture, which is what we want to see. We want to see those small weeds knocked out, roots sticking up, so the sun hits them, kills them off quite efficiently. And that's just a nice picture that shows this is a very, very similar setup as in a Verso machine to what GoFarm are using. Up the top, we have the discs to open up, and they move a little bit of soil away from the row and cut this nice clean edge, which allows the angle knives to then work in. These knives stick into the ground and then pull back away from the row, just to make sure it disturbs all that ground. And then the finger weeders come through after. So you can see in front of the finger weeders, we've still got a crust and we've still got a bit of solid ground, and yet after it, we've knocked it all about. Yeah, so quickly, I guess it's just a little bit of the technological stuff. That's pretty much where we're at. I guess, yeah, same thing, you know, we have the ability to, tomatoes, this is the first machine that we've done with tomatoes. We've got several machines in things with corn and cabbages, currently doing some trials in some broccoli. Yeah, we're just really trying to, try and find, there's so many different combinations, trying to find the best machines to work in the best conditions.
Well, good afternoon, I should say. It's Danielle Park here at Tripod Farms with Frankie Ruffo, and we've just got a short presentation around the carbon robotics laser weeder. I will get my presentation up. I also have a short video which I'm hoping will be visible and viewable, and we'll see how we go from there. So as I mentioned, my name's Danielle Park. I'm the Regional Development Officer for 3 of the key vegetable growing regions in Victoria, which we call the West, the South East and the North. And today we're having a bit of a discussion around weeder technology use in vegetable production, with a particular focus of the laser weeder that's produced by Carbon Robotics here in Bacchus Marsh in Victoria. One thing before I get on is just to give a bit of an overview. The VegNet program is focused on supporting vegetable growers to improve profitability, productivity, preparedness and competitiveness. So this definitely falls within that sort of space. And unfortunately, Carbon Robotics has been unavailable to join us today to focus a lot more on the technology. I'll provide point out a few sort of key features and point you towards some backup resources if this is something that might be of interest to you. And the other thing I will just mention, and I think one of the coordinators will put it in the chat box, is that there has been a recently announced project funded by Hort Innovation called Advanced Vegetable Mechanisation Program. And there is actually currently an expression of interest process open for any vegetable producers around Australia who'd like to go to the upcoming AgTech event in California in late October this year. It's got a fairly short timeline, so I'd encourage you, if either you or anybody you know is interested in going and having a look at the range of technologies available. Carbon robotics is US based, and there's a lot of interesting work coming out of that sort of country that might be relevant for your particular setting. So just to give you a bit of an overview of the weeder technology itself, as you can see, it's tractor drawn and goes along day and night. Not that fast for anybody who's in covering bigger territory, but in certain veg settings, it's very useful. So it's an AI guided laser weeder with high resolution cameras to identify and target weeds. So green on green, so taking a picture of every plant that it goes across and identifying friend or foe. Is it something we want to keep? Is it something we want to kill? And more recently, I know there's been some discussion when there's volunteers coming through with the in the crop rotation, identifying, do we want to keep it this time or we want to kill it this time? So that's sort of just learning that process, especially with the more specialised leafy veg crops, which can have quite an interesting sort of pattern and need to be sort of calibrated and reset for this setting. So this is just to give a bit of a visual. Like I said, in the absence of the carbon robotics technical experts, having just been to Hawk Connections and headed home for their summer holidays, what you can see here is that the laser weeder itself is tractor driven. It's going along, and it's very hard to capture these, but you can see that it's identifying a plant and then it is striking that little laser at anything that it doesn't want to be there. So it is looking to get, that's that sub-millimetre accuracy of striking and killing the weed as it goes along. So this is, as I said, it can operate in the day and the night. You can see there's a little tablet. So there are two settings to the best of my knowledge, that you can set what you want to be achieved within that block from the home base, and there's also some calibration that's needed by the operator. So there is a level of skill involved with operating this particular system, and there's also, you have to determine the kill rate, or what I call the kill rate, so that depending on the crop and the objectives you're trying to achieve, that can change in terms of what you're trying to, what your outcome you're looking for, and how you go forward. Frankie Ruffo from Tripod Farmers, just to give a bit of an overview of the production system and the weed challenges as they stand. We're currently on the Bacchus Marsh property in Victoria. You have other properties, but we'll focus just on the Bacchus Marsh property today, just to sort of give an outline of what you grow, how it operates, and some of the specifics for why you're looking at laser weeding.
Yep. So hi everyone. So Frankie Ruffo, Farm Production Manager here at Tripod Farmers. We grow leafy veg, mostly mixed lettuces, so different coloured lettuces, wild rocket, spinach. Also grow some head lettuce too, like cos and baby cosses. We produce 12 months of the year, so we're very intensive farming, so minimal rest time between crops, which creates high pressure for a bit of disease and weed pressure also. Use overhead irrigation, so plenty of water through the warmer months. So there's plenty of challenges. We've had this laser weeder now for the last 4 months, and that's definitely helping us with some of those challenges. So so far we've seen a reduction in weeds in our crops, which is in return is giving us better crops too. So less competition for the crop, and more nutrients available for the crop as well.
Is there any other reason why management of weeds in a baby leaf in a salad setting is particularly important?
Yeah, it's super important. So the consumers do not want any weeds at all in their salads. So for us, that's a big reason why we've also invested in one of these weeders, just to reduce the total number of weeds, which is challenging in our high density crops, which most of our leafy crops are very high density, so in a range of 100 plants to about 1,500 plants per metre of bed. So yeah, and the tolerance is 0 for weeds in our product. So it's a really good tool, an extra tool rather than just the historic weed management tools like hand weeding and herbicide use. So it's great to have that other option to throw at the weeds.
One of the things I highlighted was the speed of the unit. That's
Yes.
sort of something that I think a few people find a little surprising. It's
depending on the weed pressure, that really varies quite dramatically. Sometimes we've had the machine going at about 1 kilometre, maybe 1.5 kilometres, and other times it's down to like 100 metres or 200 metres per hour, depending on the weed pressure and depending on the weed size. So over the last 4 months, we've sort of learnt a lot about the machine as well. It's been quite user-friendly, so we set it up and was quite easy to get going, and we're out using it straight away. But we've sort of discovered that the timing is the main factor when we're using this machine. So getting the weeds at a smaller size increases our speed. So the smaller the weed, the less energy the machine has to put into killing that weed, which means an increase in speed. So yeah, now we're actually shooting weeds like way smaller than our little fingernail. Pretty much the smaller, the better.
excellent. So in terms of actually going down the path to bring a laser weeder onto farm,
Yep.
How did you actually go about that process? How did you identify?
Yep, good question. We sort of, my mum about 12 months ago exactly now, was looking for options to help us with our weed issue, and she came across Carbon Robotics and a few other websites that she came across, and sent out some emails to sort of see what our options were. And within a few weeks, Carbon Robotics actually came out and visited us on our farm, discussed what they had planned. I think by then they had machines in operation commercially maybe for about a year, so quite new technology. So we liked what they said. Then we decided to go over to the US last September, and we got to see a few machines in operation, and that there really sort of gave us our answer. As soon as we saw it in operation, we knew that it was something that would definitely help us on our farm.
Yep. So I think we probably already answered this, but what's been involved with getting it set up? Has there been any issues with sizes or infrastructure, or just calibrating it and getting it going, or has it been reasonably?
It's been reasonably smooth going, so quite easy to get going. The hardest part was actually just moving the wheels on the machine to match our tractor wheels. And yeah, we only had to move them about 4 inches, and that was probably the hardest part about setting up the whole machine. Everything else was pretty much plug and play. There was models there available for our crops from other people in other countries, so we started using them straight away. Carbon Robotics came out on site for quite a few weeks, helped us set up and also build our own models or adjust the existing models to capture a few different weed types that we've got here that other people don't have. So yeah, it's really basic sort of setup. And the only limitations on the machine in using it is it's about 4.5 tonne, plus the tractor's about 8 tonnes. So yeah, with our leafy crops, we sort of have to irrigate a lot. So the challenge is trying to get back in with the machine at times. It's sort of a bit easier through the cool months, but definitely through the hotter months when we're irrigating more, it's a little bit challenging to get in with such a heavy machine.
And the skill required to drive and operate, is there, what have you found in terms of, is it something that can be handled with the workforce you have, or?
Yes, yep. So you just need a really high skilled tractor operator, someone that's a little bit into tech as well, comes in handy. But in saying that, the operator app that we use in the tractor is actually quite easy to use. So you just go through, select your crop, and then that sort of directs the operator to travel at a certain speed depending on the size of the crop, the size of the weeds, the amount of weeds. So there's only a few small settings there that need to be set to get going. Every morning we have to calibrate the lasers to make sure they remain within that millimetre accuracy. So we just got to manually calibrate them. It only takes about 10 minutes, and then we're off and weeding. Yeah.
I think I saw a question before then about whether there's regrowth or how does it actually kill the weed?
Yes, yep. So it just burns with a laser right in the centre of the weed. And we find that when we hit the weeds really small, it just like annihilates them. You can't even see that weed anymore. When you let the weeds get a little bit more mature, a lot harder to kill them. It still does a really good job, you know, maybe killing 90% of the weeds, but some of those ones may grow back because, yeah, just due to their size, and that'll probably slow them down, but some will continue to grow.
And any sort of key, I know it's only been 4 months, so
Yep.
and you've had a lot of visitors come through from all sorts of different places to come to have a look.
Yep.
Are there any sort of learnings you've had from the first? Are you seeing any differences in terms of weed pressure or product quality, or like where have you sort of started to notice any differences? Are you dropping your herbicide levels back?
Yes.
In terms of pre?
Yep. Yeah, we have dropped our herbicide levels back a little bit, which is great for our crop health. We get a bit of an increase in yield and crop performance just there. We've managed to reduce. Well, we've actually stopped using methane sodium. We used to fumigate our beds sometimes prior to sowing or transplanting, just to control weeds. So we've been able to completely stop that, which is great for the environment, the operator, and also it's a pretty big cost saving with methane sodium getting more expensive the last few years, especially. And then yeah, crop performance. We've got less competition with weeds out there, so we actually do believe there's been quite a significant yield increase with that.
And so yeah, so some of the focus, I suppose, has been very much on the weed performance. There's an awful lot of data
Yep.
being captured as the laser weeder is going across and taking a snapshot of every single plant, both those that you kill and those that you keep.
Yep.
I know it's very early, like the focus has been on the weed management component, but where do you sort of see some of those pieces going into the future? Absolutely.
I think that's that's going to be, you know, some of the changes and probably pretty quickly and easily adapted to by carbon robotics possibly. You know, it's scanning our crops completely, so it's counting how many crops we actually have. So whether that's 100 plants per metre or, you know, 1,000 or 2,000 plants per metre, depending on the crops. So it's actually counting how much crop we have per hectare, and also the weed population and the types of weeds too, whether they're broadleaf or grasses, etc. So it's really given us some really good, you know, numbers and really accurate numbers.
One of the things when you first see it is that it's quite it is quite an interesting process because the weeds are being burnt. You do get quite a distinctive smell of weeds burning.
Yeah.
And it is, and it's very satisfying to see that, yes, it's just a little ash spot where the weed used to be once the laser weeder has gone over. So unless there's anything, so like I said, the weed management part is the piece that we're focusing on today, but I can foresee that there's there could be some really interesting benefits beyond just weed management.
Yes.
That environmental benefit of not disturbing the soil, that reduction in potentially of herbicides, we don't know how low that might go, and just also the sort of work health and safety benefits of having a single operator in a block as opposed to having lots of people having done that work in the past, so that those people can now be used elsewhere, potentially in a more skilled role in the business. So that opportunity to sort of increase the skill level within the property and within the business, and get technology doing it much more efficiently.
Absolutely, yeah.
So are there any questions? With your tractor fuel use?
Yes, yeah. So the tractor isn't working hard at all out there. All that's required though, it is revving, the engine's revving quite high. I think the diesel use is about 30 litres per hour, so it's a significant amount of diesel, and that's to be able to run the generator to get enough power going back to run the laser weeder.
Thank you very much, Frankie, for providing a bit of a snapshot of the first 4 months. We look forward to hearing how it goes over the next sort of, the remainder of the season to get a full summer under your belt, and then we'll see what we've come up with. So thank you very much for your time. Much appreciated.
Thanks, guys.
Yeah, thank you both very much. Thank you to the other guys as well.